Good morning, students. How are you? Today we are gonna complete our lesson in Algebra Secondary 1 and Introduction in the Complex Number. We said in the first part the meaning of imaginary number, and we knew that we put a number x squared equal -1. This number is I squared, so I squared equal -1. So it is an imaginary number, x squared equal -1. Okay. Today we are going to explain what the meaning of complex number. We know that root 5 is a real number. While 3i, for example 3i, is imaginary number. What about the number root 5 plus 3i? A part is a real number and another part imaginary number. So this number is a complex number. Complex number because it contains a part real and a part which is imaginary. So we call it complex number. Okay. Equality of two complex numbers. If we have two complex numbers, which is a plus bi, which is equal to another complex number, which is c plus di, we know that a is the real part of the complex number and the pi is the imaginary part. C is the real part and di is an imaginary part. If we have a complex number equal another complex number, that means the real part equal the real part and the imaginary part equal imaginary part. So we can say A equals C and BI equal DI, and vice versa. If we have A equals C and BI equals DI, so A plus BI equals C plus DI. Now let's take an example about equality of two complex numbers. If we have two complex numbers, two equal complex numbers, 2x plus 1 plus 4yi equals 5 minus 12i. This is an example of two complex numbers equal. Two equal complex numbers. That means the real part equal the real part and the complex part equal the complex part. So we can make two equations. The first equation will be 2x plus 1 equal 5. 2x plus 1 equal 5. So 2x equal 5 minus 1, it will be 4. X equal 2. The other part, 4yi equal negative 12i. We can cancel I with I, it will be 4i. 4y equal negative 12. So y will be equal negative 12 divided 4, it will be equal negative 3. Another example for equal complex number, if we have 2x minus 3 plus 3y plus 1 I equals 7 plus 10i. A complex number equal complex number, so the real part equal the real part and imaginary part equal imaginary part. We will make two equations. The first, 2x minus 3 equals 7. Let's solve the equation. It will be 2x equal 10, so x equal 5. The unreal part or the imaginary part, 3y plus 1 I equal 10i. We can cancel I with I, so it will be 3y equal 10 minus 1 will be 9, so y equal 3. Now let's take an exercise about the operation on complex number, adding, subtracting, multiplying complex number. Find the result in each of the following in the simplest form. Find the result of each of the following in simplest form. The first example, 3 plus 2i, 3 plus 2i plus 2 minus 5i. If we want to add two complex numbers, we can add the real part with the real part and the imaginary part with the imaginary part. We can use the properties we studied before, such as commutative and associative. Commutative to replace, to change the places of the number, and the commutative to choose the numbers we will adding together. So we can make 3 plus 2 plus 2i minus 5i. What is the property we use? Commutative and associative. Now 3 plus 2 will be equal 5 plus 2i minus 3i negative 3i. Positive by negative equal negative, so it will be 5 minus 3i. Okay, another example. Another example for subtraction. If we have 26 minus 4i minus 9 minus 20i. We can change this negative into positive and change the sign inside the bracket, so we can convert it into addition. 26 minus 4i as it is, and the negative will be positive, the subtraction, convert into addition, and change all the signs inside the bracket. 9 will be negative 9, negative 20i will be positive 20i. And make it as addition operation like the previous example. So it will be 26 minus 9 or plus negative 9 plus negative 4i plus 20i. 26 minus 9 give us 17 plus negative 4i plus 20i will be 16i.